Welcome to Ask and Learn.
Okay, so this is problem 24.93, and it's actually a diffraction grating problem. Okay, so we have a diffraction grating that has a separation distance between the slits called D. Okay, and we're going to shine a source of light which is actually continuous light in the range. So it has wavelengths in the range between 360 nanometers to 2000 nanometers. Okay, so we're going to shine this source of light on this diffraction grating, and we observed that actually the wavelengths of the first order fringe of the wavelengths, that is 1200 nanometers, occurred at an angle theta. Okay, and the question is asking what other wavelengths is that we are going to observe at the same angle theta. Okay, so I mean we can just consult the relationship that we know about diffraction grating, which is just d sine theta is equal to lambda. And in our case here, m is 1 because this is the first order, and lambda is just 1200. Okay, so the sine theta, this particular theta that will, at which we observe this lambda, the first order of this lambda, is equal to 1200 nanometers, right? And so we are looking for other combinations of m and lambda that will give us the same d sine theta. Okay, so we're looking for other combinations of m lambda that will give us 1200 nanometers. Okay, and because we know that lambda m can only be an integer, so now we know m lambda should be 1200 nanometer in order for this lambda to be observed as the same theta here. Okay, and we know that m can only be an integer, so that lambda, which is 1200 over m, so we're going to replace m with other values. So for m is equal to 1, we're going to reproduce 1200, which is what we already have. So I'm going to continuously substitute with other values of m to see if we can find other lambdas that are inside our range here. Okay, so let's try m equal to, for this case, lambda will be 1200 over 2, which is 600 nanometers, which is inside this range. So this one, well, we will observe this one at the same theta. Okay, let's try m equal 3. Lambda for this case would be 1200 over 3, which is 400 nanometers. Again, this is inside this range, so this will be observed as well. Now m equal to 4, lambda will be 1200 over 4, which is 300 nanometers. Oh, this one is outside this interval, and so any larger value of m will be outside this interval as well. So the other wavelengths that we can observe at the same theta here will be just the two wavelengths that we have counted, that we have calculated, which is 600 and 400 nanometers.